Welcome to this discussion about solving polynomial equations. And in this video, we are going to focus on just how do we use the remainder theorem to evaluate a polynomial. So let's talk about what is the remainder theorem. Okay, so let's think about this quotient. We have a division problem, f of x divided by x minus c. And we're going to say f of x is a polynomial. And of course, x minus c we know is a polynomial. So this is just polynomial division. So what if we divided this? What would our answer look like? And usually what we find is we end up with another polynomial, which we're going to call q of x here, and potentially a remainder. Okay, and remember that we can write a remainder as the remainder over that divisor, x minus c. Okay, so now let's think about what does that mean about what does f of x equal? Okay, so if I wanted to solve for just f of x here, I would multiply everything by the quantity x minus c. So I'm just going to multiply everything by that quantity x minus c. So let's think about that. I have two things within this big set of parentheses and then this x minus c. I am going to distribute this x minus c times the q of x and times this r divided by x minus c, and that will give me this. X minus c times q of x plus just that remainder, the r part. So what if we took that f of x that we know now to be equal to x minus c times q of x plus r, and we evaluated f of c? That means that we would replace x with c here and here, right? So f of c would end up being c minus c times q of c plus r. Okay, but what happens here? That c minus c becomes 0, and 0 times anything is just 0, and so f of c would just end up being r. Okay, so that means that if I'm evaluating any number, f of some number c, that would mean I would get whatever I got as the remainder when I divided by x minus c. That's interesting, and that is something we can use. Okay, and that is actually the gist of the remainder theorem. The remainder theorem is implied by this whole idea. If a polynomial f of x is divided by the expression x minus c, then the remainder is nothing more than f of c. Okay, so let's think about that again. The remainder is equal to f of c. Say that again. The remainder is equal to f of c. Okay, so how is that important? Well, that means that we can use the remainder theorem to evaluate. Remember how fast synthetic division is? That makes it really fast to evaluate these things. Okay, so if I want to evaluate f of negative 4 and I'm using the remainder theorem, I'm just going to use synthetic division and pull the remainder. So let's do that. Okay, so here is a synthetic setup. And remember that what goes in the box is what is equal to x. And so that is going to be our x value. So negative 4 goes in the box. Setting up our coefficients. First, I'm making sure I'm in standard form. Second, I'm making sure I don't have any terms missing. So I'm good. So I'm just going to pull those coefficients and bring them down. All right, remember that to start synthetic division, I just bring down that first coefficient and now multiply that 3 by the divisor there, which is negative 4. So 3 times negative 4 is negative 12. So negative 12 plus 4 is negative 8. Then do it again. Negative 8 times negative 4 is positive 32. Add that to the negative 5, I get 27. Multiply that 27 times negative 4, I get negative 108. And when I add that to that positive 3, I get, oops, negative 105. Now, I wanted to remind you that what I'm doing is looking for the remainder, right? I'm using the remainder theorem that says the remainder is f of c. Okay, so I'm looking for f of negative 4, and this is my remainder. And so that is my answer. F of negative 4 is negative 105. Okay, and so let's do this other example. Or if you want to try this other example, pause the video and work ahead and then come back and check it. Okay, same thing. It's the same thing with a different function. So f of x is equal to 5x to the fourth minus 2x squared plus 6x minus 1. So we're going to set up our synthetic format. We're going to put that negative 4 in the box. We're going to put our coefficients where they belong. We're in standard form, but we're missing something. Notice I'm missing a cubed term. So I need a 0 placeholder where that cubic term would be. So my coefficients will look like this. And I'll step through that process. Bringing down the 5, multiplying by negative 4, adding negative 20 to 0, multiplying by negative 4 gives me 80, adding that to negative 2 gives me 78, multiplying by negative 4 gives me negative 312, adding that to 6 gives me negative 306, multiplying that by negative 4 gives me 1224, and then adding that to negative 1 gives me 1223. Again, I'm looking for the remainder because that is f of negative 4, and I'm done. Now, one last comment about that before we wrap this up. I'm using synthetic division to find f of negative 4. All right, that's a little bit different than actually doing a polynomial division problem. I'm doing the same steps, but I'm interpreting it differently. I'm using it for a different purpose. Okay, so if I just said I want to divide 3x cubed plus 4x squared minus 5x plus 3 by the quantity x plus 4, I would do exactly the same thing, but it would interpret my answer different. I would interpret these things as the coefficients of a polynomial. Okay, but for this, I'm just evaluating f of negative 4, so I can just pull the remainder. So I'm using that synthetic division. I'm just using it in a different way as just purely dividing the two polynomials. Okay. That was my last comment for this video. And in the next video, we're going to move on into the factor theorem, and I will see you then.